Welcome to this video tutorial, one of many in a series designed to get you up and running with Leapfrog. In this video, I'm going to show some of the other geological modeling tools available, including faults, model copies, static copies, refined models, and combined models. I'll start by showing you how to incorporate faults into your model if necessary. In this example, I'm going to use meshes that I'll import into Leapfrog. I'll start by introducing them into the project using the Meshes folder. Right-click, Import Mesh. You can multi-select as many meshes as you have and import them all at once. You will typically leave the defaults in the cleanup mesh selected and click OK. Now that the meshes exist in the project, we can use them as faults in the model. To illustrate how Leapfrog incorporates faults, I'll create a new geological model. I'll set up the model by first selecting a base lithology column. I will enclose my geology drilling segments, and I'll reduce the resolution to 20 and click OK. Now that I've created a new geological model, I can introduce the faults in the fault system by right-clicking New Fault. As you can see, faults can be created using a number of different data types. The only requirement is that the fault completely intersects the boundary of the geological model, otherwise Leapfrog has no way of producing the fault blocks. In this case, of course, I'm going to use the surface that I've just imported. I'll select Fault 1 and click OK. This is an error that can occur if you've imported faults from another software. As we can see, the fault surface is too small to stretch beyond all the boundaries of this model. In this case, we can see that the faults don't quite reach the bottom boundary. So what I can choose to do is edit the GM extents and just tuck that up a little bit inside the faults and click OK. If you're unable to change the boundary of your geological model, there are other things you can do to modify the size of the faults. Now that I've incorporated the first fault, I'll right-click it again, New Fault, from Surface, and select the second fault. Now that I've created the faults from these surfaces, I'll clear the scene and take a look at them. We can see that the newly created faults have turned pink and orange, and they have been now trimmed to the model extents. Once the faults are entered into the fault system, we can tell Leapfrog which faults are younger and older and whether or not the faults terminate against one another. To do this, double-click on the fault system to open it. Use the Younger Older buttons to specify the ages of the fault. To add an interaction, you can click the Add button below. However, please note that interactions cannot be added for the youngest fault, as it is assumed that the youngest fault will cut across all other faults. In this case, I'll have to select Fault 2 to be able to create an interaction. I'll create the interaction for Fault 2 by clicking Add, and then I need to decide what that interaction will be. In this case, I'd like to have it terminate against Fault 1. This can be changed by a drop-down, but of course here I have nothing to change it to. And lastly, I need to decide what side of Fault 2 I would like to keep. Would I like to keep this side of Fault 2 or this side of Fault 2? How you decide depends on what side of Fault 1 that actually falls on. As I can see, if I'd like to keep the northeast side of Fault 1, I would keep that as northeast. If I would like to keep the southwest side of Fault 1, I would select southwest. In this case, I'm going to select the northeast side and click OK. We can see right away that fault has now been updated to terminate against Fault 1, keeping the northeast side. Now that we've seen the faults, I'll tick the check boxes to activate them. Activating the fault will break the model into the appropriate number of fault blocks, as we can see here. Each fault block acts like its own submodel within the main model. Activating faults can be done before or after surfaces have been built up in the model using surface chronology. If a model is faulted after the surfaces have been built, the existing surfaces will be split into the respective fault blocks. And if a model is faulted before the surfaces have been built, which is true in this case, Surfaces built in one block can then be copied to the empty fault blocks so there isn't too much work to repeat. When it comes to build surfaces first or fault first, there's no real best overall approach. It will really depend on your project and your personal preference. Either route will give you the same results in the end. Now that we've seen faulting in Leapfrog, let's take a look at some of the other models that Leapfrog can produce. Since models can be built relatively quickly, it allows for the time to test out multiple interpretations. To make that easier, Leapfrog has the ability to copy models so that you can change a couple of parameters without having to start a model from scratch. There are two options for copying, and both of them are available by right-clicking the top level of any of your models. The first option is just a straight copy of the fully dynamic model, which allows you to test those other interpretations. This copy will update with new drilling or new edits. Leapfrog also has the option to create a static copy, which is just what it sounds like. A static copy is an exact copy of the model as it stands now, but it will never update when new data is added to the project. It is like a timestamp of a model that allows you to show how the interpretation progresses as you add new data. We can see here that the static copy contains the boundary, a fault system if one is present, all the surfaces in the surface chronology, and the output volumes. The static copy can be visualized in the scene, but as mentioned, it cannot be updated or edited. There are a couple other model types available in Leapfrog, and they are the refined model and combined models. Refined models give the user the ability to take a particular lithology within a geological model and refine it. For the example that we used in these video tutorials, we could create a refined model of the miscellaneous sediments unit and then use the strat column to produce different surfaces within that unit. Another possible example is an intrusion which contains multiple phases of mineralization. We could create a surface representing the entire intrusion and then create a refined model within that intrusion to represent the more detailed multiple phase model. Essentially, refined models allow you to refine any volume from an existing geological model with a different column of data. To create a refined model, there must be an existing geological model. To set up the new refined model, simply right-click on the Geological Models folder, as I did, and select New Refined Model. The first thing we'd like to do is select the model I'd like to refine. In this case, I'll refine the simple lith model. Next, I need to select the lithology within the original model that I wish to refine. After I've defined that, I'll set up the base lithology column I wish to use for my new refined model, and then I set the surface resolution, give the model a name, and click OK. We can see now we have the new refined structure model for our original simple lith GM. Within the refined model structure sits the entire original geological model, and now we also have the new section which represents just the original miscellaneous sediments. To build the surfaces up in the refined model, we'll right-click Surface Chronology underneath the refined model heading, and we can go through and we can create surfaces just as we've seen done before. Once we've built all of the surfaces necessary within the refined model, we'll be able to see it has its own set of output volumes, and then the entire model as a whole will have its output volumes. If for any reason you ever need to delete a refined model, ensure to delete just the volume that you're refining and not the overall model. Lastly, I'll touch on combined models. Combined models take volumes from up to 4 different types of models, including geological, interpolance, and distance functions, and then cuts them against each other to produce a series of subvolumes. This is a good way of visualizing the relationships between different models in the project. There are a number of possible uses for this. First, you could use them for combining a geological model with a weathering model, which allows you to check which parts of the mineralized lithology are weathered to different levels. Or you could combine a geological model with a grade model to visualize where the high grade sits within each lithology. Or you could also combine a grade or geological model with the model created from different pit shells to see what volumes would exist in the different pit sizes. Combined models are very easy to create. In this case, we will combine a geological model with a weathering model to check which parts of our mineralized quartz porphyry intrusion are highly weathered. To create a combined model, simply right-click on the Combined Models folder and select New Combined Model. We'll then tick the check boxes for the two models we wish to combine and then click OK. Next, we need to decide which of these volumes we actually wish to combine. There is a tip at the bottom of the window recommending that the models with the fewest volumes be placed at the top to reduce processing time. In this case, I'm going to select just the quartz porphyry and all three of the weathering volumes. So in this case, it's best to leave it as is. Now that I've selected the volumes I wish to combine, I can click OK. Let's take a look at what Leapfrog actually sets up with the combined model. First, we can see it shows the two different models we've chosen to combine, and then the set of output volumes. In this case, we only had our quartz porphyry as an output volume from the strap model, but that's now been broken down to the oxidized zone, the mixed zone, and the primary zone. If at any point we wish to modify this combined model, we can simply double-click the combined model heading and select another volume. These volumes will then be created as well. In this case, the granodiorite has no oxidized volume, but there is the mixed and the primary. If I click on any one of these volumes, I'll get some basic stats about the volume and the area that it has.